Welcome. In this video, we're going to consider this function f of x equals x to the 1/3 times the quantity x minus 4. We're going to do several things here. We're going to look at identifying the critical numbers. Those are possible locations of maximum and minimum values. We're also going to identify intervals where the function is either increasing or decreasing. And then we'll state local as well as absolute extreme values. Now we have a couple of pieces of information here. One, we have that original function. The original function gives me points on the graph. So if I just want to know at x what is y, I go back to the original function. However, the derivative, that is going to give me these critical numbers, and that's going to be super important for us to try and determine where there's a max or a min value, as well as our intervals where the function may be increasing or decreasing. Once we've broken the function into separate intervals, we're going to choose test values, and we're going to test those values in the derivative f prime of x to determine if the graph is increasing or decreasing. And of course, if the graph is increasing and then changes to decreasing, that might indicate a max. Or if the graph is decreasing and then turns around and begins increasing, that could indicate a minimum. All right, so that's what we're going to do in this problem. We're going to find the derivative, set the derivative equal to 0 to determine the critical numbers, and then we're going to look at a number line broken into intervals and test values to make conclusions. So the first thing I'm going to do here is look at finding that derivative. And in order to find the derivative, f prime of x, I'm going to need to use the product rule. And the product rule says first times the derivative of the second. The derivative of x minus 4 is just 1, plus the second, x minus 4, times the derivative of the first. And the derivative of the first, using the power rule, is 1/3 x to the negative 2/3. So this is my derivative, but of course I need to clean it up a little bit. So f prime of x, well, the first term is just x to the 1/3 power. And then distributing here, we're going to end up with plus 1/3 x, that's x to the first, and then we add negative 2/3, we get a 1/3, and then minus 4/3 x to the negative 2/3. Of course, in this situation, we can combine like terms. So f prime of x, 1 x to the 1/3 plus 1/3 x to the 1/3, that is 4/3 x to the 1/3. So I have 4/3 x to the positive 1/3 minus 4/3 x to the negative 2/3. And then our last step when we're dealing problems like this is to factor out a GCF. Of course, you should notice both of my terms have a 4/3 and they both have an x. Now remember, we want to factor out the least quantity of x's. So I have here f prime of x equals, I'm going to pull that out, 4/3 x, and the least amount is negative 2/3. Of course, what does that leave us with? Well, looking right here at the 1/3, take away negative 2/3. 1/3 take away negative 2/3, that's plus 2/3. We end up with x to the first. And the second term, we just factored all of that out, so it just leaves us with 1. So I'm going to come up here, I'm going to rewrite my derivative. I'm going to clean that up. This is 4 x minus 1 slides into the numerator. 3 was already in the denominator, and then the x to the negative 2/3, I'm going to put that in the denominator and make it a positive 2/3. So that is my derivative. I always encourage you to pause and make sure that you are right on track with my work. So now what we're going to do is we're going to find the critical numbers. And the critical numbers, of course, occur where the derivative is equal to 0 or the derivative is undefined. And of course, in this situation, if we're looking at our graph, well, if we set this equal to 0, our derivative, if we're looking at the derivative and we set it equal to 0, we would just be looking at the numerator equal to 0. And that's going to give me the numerator is equal to 0 at x equals 1. Are there any undefined values for this derivative? Of course, the denominator cannot equal 0. So 0 is the value that would turn that into 0. So I have 2 critical numbers. Now at this point, we're going to take those critical numbers and we're going to put them on a number line, and this is where we get into the testing. And those 2 critical numbers are going to divide my number line into 3 separate intervals. So I'm going to plot x equals 0 and x equals 1 on my number line. And of course, as I said, this breaks that number line into 3 intervals. We have negative infinity to 0, we have 0 to 1, and then we have 1 to positive infinity. Now, I want to choose a test value on each interval, and it can be any number I want, just within reason. So a number that is less than 0 could be negative 1,000,000. I'm going to choose negative 1. A number between 0 and 1, unfortunately, we have to choose a fractional value here, and then a number greater than 1, I might choose x equals 2. So I have 3 test values. And of course, I want to test these test values in my derivative. So my derivative, I'm just going to write that down here. We've got 4 times the quantity x minus 1 over 3 times x to the 2/3. And when I'm looking at testing these values, I don't want to figure out exactly what the output is. I just want to know if the output is positive or negative. Because remember, the derivative is telling us about slope. So if the derivative is positive, then we're going to be increasing. And if the derivative is negative, we will be decreasing. So I do this in kind of a special way when I look at it and I think about, well, what happens to the numbers when I plug them in? So for example, f prime of negative 1. If I put negative 1 in my function right here, that's 4, and that would be times negative 2. So that's a negative in the numerator over, now in the denominator here, when I square that, that becomes positive. So it doesn't matter if I cube root it, it would still be positive, times 3 would still be positive. So I have negative over a positive, and a negative over a positive is, of course, a negative value. So I know that the graph is going to be decreasing from negative infinity to 0. Now let's try this again with another value. So let's look at f prime of 1/2. So what happens if I take that 1/2 and I plug it in here? 4 times 1/2, well, that's 4 times a negative value. So that would be negative in the numerator, and 3, plugging in 1/2 to the denominator, that would be a positive value. So negative over positive is again negative. So again, we are decreasing on this interval from 0 to 1. So it stands to reason that we are decreasing everywhere from negative infinity to 1. We just merge those 2 intervals together. And since there is no change, we are going down left to right, and we continue going down left to right even after we hit 0. There is no max or min because there's no change in sign from negative to negative. We do not have a maximum or a minimum value here. All right, let's look at one more. Let's say f prime of 2. We will test our third value. So 4 times 2 minus 1, that's going to be a positive in the numerator. And of course, plugging a positive in the denominator will give us a positive. So we have positive over positive. That's a positive slope or positive derivative, which lets me know that the function is increasing. And we are increasing on the interval. That interval is written up above there, but we are increasing from 1 to infinity. Now, of course, we have one other item to talk about here. Since we changed, we were going down and now we are going up, what is happening likely at x equals 1? I wrote max, but that's not what's happening. We have, if we're going down and then we're going up, we have a minimum value. So a minimum at x equals 1. And of course, you remember, we always say the max or min is y at x. So in order to find that minimum value, we're going to plug that into the original function. So the minimum is f of 1 at x equals 1. Of course, if we go up here to the function, if I plug in 1, that's 1 to the 1/3 times 1 minus 4, negative 3. We have 1 times negative 3. The minimum is 3 at x equals 1. So our answers, we have the interval where the function is decreasing, we have the interval where the function is increasing, and we know that we have only a minimum value. So let's take that and connect that with the graph. So I have pulled the graph in here, and you notice the graph is going down all the way to 0. We hit 0, we still are decreasing. And then once we hit x equals 1, you can see a very obvious turnaround. You see that minimum occurring at 1, I said negative 3, I didn't write it, at 1, negative 3. Okay, so the minimum is negative 3 at x equals 1. All right, is that a local min or an absolute min? And it is an absolute minimum at x equals 1. Is it also a local minimum? Sure. It's also a local or relative minimum, but it is the absolute lowest point for the graph. Does the graph have an absolute max? And because the graph is extending up to positive infinity on the left and right forever, there is no absolute max. There's no local max either. Okay, so that 1 point, 1, negative 3, that is the minimum value. It's the absolute minimum and the local minimum. And then there is no absolute max or local max in this situation. But of course, those maximums occur whenever my graph is changing from decreasing to increasing or vice versa. As always, please let me know if you have any questions or concerns, because I would love to help you understand this better.